So we have radioactive decay. It's decaying exponentially. So we have an exponential equation here. Y equals some starting amount A times some exponential rate B to the power of T, where Y is the amount of milligrams we have after T time period. So they begin with 100, so we can plug that in for A. 100 is the starting amount. We don't know what B is directly, but they tell us after 35 hours, Y equals 50, because Y represents how much you have, how many grams, or milligrams in this case, you have after a certain amount of time. So we just got to do a little bit of algebra to help us solve for B. Okay, so you can divide 100 from both sides. I'll type it out because it's a little quicker. So divide 50 by 100, you get 0.5. And then in order to get B by itself, we have to get rid of that exponent of 35. So we could use a rational exponent. We could raise both sides to the power of 1 over 35. That way, powers on top of powers multiply. So I'm going to raise this side to the 1 over 35th power. I'm going to raise this side to the 1 over 35th power. And then that gets us B by itself over here. And so I'm going to use an approximation in my calculator. 0.5 to this power. Okay, so that's what B is. 0. It's exponential, so you probably want to carry several decimals. That's what B is. So now we can answer their question, how many milligrams? So what is Y? When we have a starting amount of 100, we have this for B, and then for T we have 54. So now it's just plugging it into a calculator. So we got our big long decimal, I'm raising that to the 54th power times 100, so it looks like you're going to have 34.32 milligrams left over.